Okay, so here we are, Unit 3. We're going to be looking at, it's going to be a lot of graphing. And so the first thing we're going to look at is graphing what's known as a quadratic function. And so first we'll kind of look at how they look. And then from there, we'll kind of go and look at how the equations are set up and how to find information about them. So first, let's just go ahead and dissect the parabola. So you can see it's the U-shaped uh, right here on my graph, our bowl shape, however you want to look at that. And so we have a vertex. That's going to be known as the highest or lowest point. In this particular example, it's the lowest point. But sometimes the parabolas will open, we'll say downward. Okay, so sometimes they open downward. And so then the highest point is the vertex. And then that's also known as your maximum or minimum point. So on the graph that's given, that's our minimum point, and then this little side graph I made, that would be known as your maximum point right there. That'd be the highest point of the graph. And then our axis of symmetry is just a line that basically cuts straight through it, and it's a mirror image on both sides, so that if I find a point here, I can reflect it across the axis of symmetry to find another point on the other side right there. And then x-intercepts, sometimes they're going to be called zeros, solutions, or roots. And so all four of those are synonymous with x-intercepts right here. And we just use them in different contexts. Typically when we're talking about graphs, we'll call them x-intercepts. But sometimes when we're using equations, we'll call them zeros, solutions, or roots. So typically with graphs, we'll use the terminology x-intercepts. And then we have our y-intercept, which is right there. Okay, so what we're going to do on this first part is we're going to use that graph to go ahead and list all this information here. And so the first part, it asked me for the vertex, and so we're just going to give that ordered pair, which is going to be at 1, -4. That's where we're located down here. And then AOS stands for axis of symmetry, and so that vertical line, there's actually an equation for it, and it's going to be x equals 1. And what you'll notice is the axis of symmetry right there is always going to be x equals the x value from the vertex. So it's just that line right there. And so you'll see that pattern, that axis of symmetry is always going to be x equals the x value from the vertex. Okay, let's see our x and y intercepts. And so we can list those two different ways. We can put them as ordered pairs, where we would say -1, 0, and then our other ordered pair would be at 3, 0. Or if you want, we could use set notation, and when you use set notation, you don't put the ordered pairs, you just put the x values for where they're located on the x-axis. So be careful. If they ask you for the x-intercepts, just read and see if they want it as an ordered pair or if they want it in set notation. Okay, our y-intercept, let's see, that's going to be at 0, -3, or once again, set notation would just be -3 right there. Maximum or minimum, we're looking at a minimum on that example right there because that's the lowest point. And then the last part is the range. Well, the lowest point is at there we go, is at -4, and it goes up indefinitely, so it goes up to infinity right there. Want to make sure we have a bracket. The only time we use parentheses is for infinity, or if you see an open circle on the graph, and we're not going to run into open circles dealing with these, at least in our particular examples we're going to see in this course. Okay, so I've got a couple more of these graphs, and it's basically asking the same things again. So let's see our vertex here, right here, let's see, that's going to be at 2, up 4. Axis of symmetry is going to be x equals 2. Just going to be what cuts it right in half right there. And then the x-intercepts, let's see, I'm just going to use set notation. We have one at 0, and we have one at 4. Okay. Y-intercept, we have one at 0 also, so they share that right there. This one is going to be a maximum, and that maximum point is actually up at 4. I'm actually going to go ahead and list that there. And then the range, well, that's the highest point, so it goes down indefinitely. So it's going to go from negative infinity, and then we peak at 4 right there. Right? Here's another one. So let's see, the vertex this time is going to be at, let's see, -1, 0. Once again, the axis of symmetry will be the x equals the x value from the vertex. And then we have, this time we have a single x-intercept, and that single x-intercept is going to be at -1. Our y-intercept looks like it's at +1. And then this one, for our particular case here, it's going to be a minimum, and that minimum value, be careful, is at 0. That's where it dips down. It dips down right there at 0. So we're talking about the y value whenever we talk about max and min. And then my range goes from 0 and then goes up. Once again, range refers to the y values. I think I have one more example of this here. All right, so our vertex on this one's going to be is located at -2 up 1. Axis symmetry will be x equals -2, just cutting right through there. X-intercepts, this time actually I have none. So that's possible also. Most of the time they have 2, sometimes they have 1, and sometimes they have none. And then let's see, we should always have a y-intercept though on these, and so that's going to be at 5 right there. By the way, on the homework, they're going to ask you the domain on most of these, and the reason I'm not asking it is because it's always the same. The domain on all of these are always from negative to positive infinity. So that's one thing that I kind of skip over, and the reason why is because it's always the same. So just be aware of that. Let's see, minimum, and our lowest point is going to be at +1 for my y value. And then so my range is going to go from 1 up to infinity. And so another pattern you probably have noticed is that the max or min is dependent on the y value of the vertex. Because the vertex is, those are synonymous. They are the max or min, just depending on how the parabola opens up. But that you have probably noticed that pattern also there. Okay, so looking at the graphs, that's always fairly simple because you just look and write down the information. When you're given an equation, it can be a little trickier, but we'll get there. Let's see. So let's start with standard form. So we're going to have a couple different forms that we can put these in, and so we'll start with standard. Standard, also kind of known as vertex form, and the reason why is because it's going to be pretty easy to figure out the vertex when it's in this format. It's always difficult whenever you look at a formula and it's all letters, but what you need to remember is the letters are going to represent information that we can extract from it. So don't be too overwhelmed right now. Once we actually look at a problem with numbers, it'll come to you a little bit easier. So one stipulation is the front value cannot be equal to 0, because if it is, then we don't have a square. And so whenever we're dealing with quadratic equations, there's always going to have to be an x squared, and you can't go higher than that though. So if you end up having an x cubed or something, that's not going to be a quadratic function. So you always have to have at least an x squared, okay, and then you might have some other values with it, but you can't have any higher powers. So the graph of f is a parabola whose vertex is located at hk. So it's going to be those values right there. Now you'll notice with the h, there's a minus there, okay? And so we'll talk about that because that will affect the sign of your vertex, and we'll talk about why that is in a moment. And then the plus k, once again, that will affect your sign right there for the y value of your vertex. So the parabola is symmetric with respect to the line x equals h, which we already kind of saw earlier that it's always going to be x equals x value from the vertex. Now the a value in front right here, that value determines if the parabola opens upward or downward. And so if the a value is greater than 0, which basically just means positive, then it's going to open upwards like this. If the a value here is negative, then the parabola is going to open downwards. And once again, we're going to look at an example and talk about it, and you'll get a better kind of feel for it. So you're not going to have to memorize all this stuff. Once we look at a couple of examples, you'll see why those affect it in that way. So let's start here. So it says find the vertex axis symmetry and tell whether the parabola opens up or down, and then go ahead and give the range. Okay, so the vertex is going to be given by these two values right here, and if you notice, it does match my formula here. So my vertex right here is going to be, now it's not going to be -3, it's going to be +3, +1. Now why is that? Well, if you plug in a 3 for x, if we plug in 3 for x, what happens is this whole thing is going to go away. Because if I plug in 3, I'm going to get 3 minus 3, which is 0. Now, I'm going to go ahead and show this. I want to make sure this really makes sense to everybody, okay? Because this is crucial. So if I plug in a 3 for, I'm sorry, not 0. If we plug in a 3, we plug in 3 for x, we'll end up with 3 minus 3 raised to the power of 2, and then we have a +1 right here. Well, what happens here is this becomes 0 to the power of 2, okay? And 0 squared is still just 0. So we end up with 2 times 0 plus 1. And then we end up with 0 plus 1, which is 1. So whenever I plug in 3, it causes what I put here in a blue rectangle. It causes that to just basically 0 out. And I'm just left with the +1. Okay? And then my axis of symmetry will be x equals 3. Now, here's where we got to figure out the max or min. Basically, does it open up or down? And so since my a value is positive, it's going to open up. And so if it opens up, it's going to look like this. So that means I have a minimum point right there. And that minimum point is going to be the y value from the vertex. And so I'm just going to go ahead and include that information right there. Now, once again, if we want to take a little deeper dive so we can kind of understand why is it a minimum? Why is it at 1? Well, remember, if I plug in 3, this will 0 out. If I plug in anything else for x, what will actually happen is I'll get a positive number. Even if I plug in a negative, even if I plug in a negative number, no matter what, I'm going to get a positive result in this blue rectangular box right here. The only value that makes it equal 0 is 3. Now, why is that? It's because of the squared value right there. So even if I plug in a negative value, like, let's go ahead and try one. Let's try f of, I don't know, we'll try -1. If I plug in f of -1, we're going to get 2 times, and then -1 take away 3 would be a -4, right? And then I have to square it, and then I have to add 1. So see what happens here. Remember, this is my rectangular box of information right here. And so -4 to the power of 2 actually turns into a +16. Then I have to multiply it by 2, which is 32, and then I have to add 1 to it. I end up getting 33. So basically, if I plug in anything other than 3, I'm going to get positive big numbers, bigger than 1. And so it's going to go up. Whether I plug in 4, 5, or 6, or if I plug in 2, 1, or 0. What's going to happen is it's going to start going up on each side. Okay, let's look at the range. So the range, I kind of have a feel for how it looks. I know that it's a minimum, the lowest point's at 1, and I know it opens up. So my range is going to go from 1 up to infinity. And that's my range right there. All right, let's look at another one of these here. So this time I've got f of x equals -2 times x plus 1 raised to the power of 2, and then a +5. So you have to be a little careful on this one. So my vertex is right there. I've got the +1 and the +5, but it's actually going to be at -1 and then +5. And the reason why is because, once again, that -1 would cause this space right here, cause this part of my equation to zero out. If I plug in -1, this zeroes out. I'm left with the +5. So real quick, if it was a -5, then it would be a -5 as my vertex, okay? So whatever the sign is on the outside right here, you're going to keep that right there. So if it's plus, keep it positive. If it's minus, you'll make it minus. On the inside part right here, you're looking at the parentheses. You're really kind of trying to figure out what causes this to zero out. And it's the opposite of what's right here. Okay, so -1 plus 1 causes it to zero out. And that's how you find your vertex right there. Axis of symmetry will just be x equals -1. Now, in this case, our a value, the value in front right here, is negative, so it's going to cause it to open downwards, which means we're dealing with a maximum height right here. And that maximum height, once again, is found from the y value of the vertex, which is up here at 5. And then our range, so we have a highest point, but we don't have a lowest point. So this thing can go down to -infinity, and then the highest we're going to go up to is 5. And once again, we'll bracket that 5 in. And so once again, you know, if you are struggling with this, what I would suggest is go ahead and make a table and start plugging in some points. Like plug in, you know, f of 0 and see what happens. Or else plug in, you know, f of 2. And what's interesting is you will actually get the same, oh, I'm sorry. Let me see. Oops, -1. Let me see. Let me rewrite that. 0. If you were to plug in 0, I'm sorry, or -2. If you were to plug in f of 0, what would happen here is you'd get 1 squared, which is 1, and then 1 times -2, and then add 5 to it. So let's see, what would that give us? Let's see, if I plug in 0, 1 squared is 1, times -2 is -2, plus 5 is 3. Let's see if I plug in -2. Let's see what happens. If I plug in -2, when you add 1 to it, it becomes -1. This would be -1. -1 squared would actually turn back to a +1. -1 to the power of 2 is -1 times -1. So negative times negative is +1. Times -2 is -2. Then add 5 to it, and I also get 3 for it. Okay? And so see, it's that axis of symmetry that's cutting through it. So that maximum point, let me go ahead and list it here, is at -1, 5, right? And so then if I plug in 0, which should be about right here, it's not quite as high. It's right there at 3. And then if I plug in -2, I'm also at a height of 3. So you can see that axis of symmetry cutting right through the parabola. Okay, now we're going to look at the general form. And this might be a form you might be more familiar with. And so we're going to just approach it a little bit differently. So how to find the vertex of a parabola whose equation is in general form. So here's our general form. F of x equals ax squared plus bx plus c. And so here's, if you look at number 13, you can kind of see an example of what that equation looks like. And so we've factored a lot of those in the first unit. And so we will actually be factoring that too in a moment. But let's go ahead and read how we're going to find the vertex. So when given a parabola equation in general form, you can find the x-intercepts and the vertex by the following expression. So if we use, the x value of the vertex by using the following expression right here. So -b over 2a. Once you have the x value, you can go ahead and just plug it in, and then you can find the y value of the vertex. And then note, the a value in general form still determines the direction of the parabola. So the a value in front will still determine whether it opens up or down. Okay, so first we're going to start by finding the x value of the vertex. And so you have to do this formula right here. -b over 2a. And so just like when we did the quadratic formula, it's still the a, b, and c. So let's see, that's going to be -8 over 2 times 2. So we end up with, +8, right? Double negatives, +8 over 4, which then reduces to a 2. So we found the x value of our vertex. And then to figure out the y value, all you have to do, because they're partners, right, x and y, just plug it in and you can figure out the y value. So now we'll do f of 2. So we're going to get 2 times 2 squared minus 8 times 2 plus 3. So then we're going to get 2 times 4 minus 16 plus 3. And let's see, we're going to get 8 minus 16 plus 3. 8 minus 16 is negative 8. Add 3 to that, and that will give us negative 5. Okay, so that's how you find the vertex whenever you have it in general form, right there. Now, axis of symmetry, once again, it's always just x equals the x value. Maximum or minimum, okay, so looking at this, let's see, the a value is positive, so that means we're going to open up. So that means we're dealing with a minimum value. And that minimum value, see, this is the vertex right there, 2, negative 5. So the lowest point is at negative 5. So my range is going to be from negative 5 up to infinity. And actually, I guess it's not asking for the x-intercept, so we don't have to factor yet, but we will in a moment for some of the other ones. All right, let's try one more of these. So same deal, we're going to use the formula x equals negative b divided by 2a. And so let's see, that would be negative 2 over 2 times, and then my a value here is negative 1. So a, b, c. So the double negatives on top will become positive 2. And then 2 times negative 1 is negative 2. And then when we simplify that, it's negative 1. So that will be the x value of my vertex. Now we'll go ahead and plug that in to figure out the y value. And don't forget, you do have that negative out in front. It's not part of what's being squared. So I'm going to square the negative 1 in a minute, and then we'll deal with that other negative on the outside. Then let's see, minus 2 times negative 1, and then plus 8. So when I square this, just bring the negative down that's on the outside. Negative 1 squared, negative 1 times negative 1 is positive 1. And then a minus 2 times negative 1 will turn that into a plus 2. And then we have a plus 8 right there. So let's see, negative 1 plus 2 is 1. And then 1 plus 8 is 9. That will be our y value there. And then axis symmetry, once again, will just be x equals negative 1. And then this time our a value is negative, so we're going to open down. Okay, so there's my vertex. It helps to draw a picture a lot of times to answer the last two questions. So let's see, that's going to be a maximum, and that maximum height is up here at 9. And then my range, so we always want to go from lowest to highest. So negative infinity, and we peak up at 9 right there. Okay, so I'm going to go ahead and stop here, and I'll make a part 2 for when we start to graph them.